Hello everyone, welcome to another video. This is another video on section 8.5. It was a problem that was requested from another student. It happens to be number 3 on your homework this semester. It's a hypothesis test for a variance or a standard deviation, which means we're going to be using the chi-square test. Note that the answers in your answer key here are not the entire hypothesis test. She gives you the claim, the alternative hypothesis, the null hypothesis, and then the final result. So she leaves out some of the steps. Just know that when you're looking at it, I'm going to do the whole process for you here so you see it one time. This is section 8.5, number 3. The problem reads like this. For exercises 3 through 9, assume that the variables are normally or approximately normally distributed. Use the traditional method of hypothesis testing unless otherwise specified. Test the claim that the standard deviation of the number of aircraft stolen each year in the United States is less than 15. So my claim is about the standard deviation. It's less than 15. If a random sample of 12 years had a standard deviation of 13.6, use alpha equal to 0.05. So let's come over here and let's use the whiteboard and write what we know down. So our parameter here, before we start our hypothesis test, let's do our parameter here is population standard deviation. And the symbol for that is sigma, okay? Not sigma squared. Remember, sigma squared is variance. So just sigma, okay? Now, my claim, if you'll remember, let's go back. It says, test to claim that the standard deviation of the number of aircraft stolen each year in the United States is less than 15. So, for the purposes of what I've shown you before, this was in a previous video, okay? I showed you the trick about recognizing your symbols. Your claim here is that your standard deviation is less than 15. So this is sigma less than 15. This is my claim. And this actually goes with H1 because there is no equal with this. So this is H1, sigma less than 15, just to remind you, but that's where we're going. So now, and this is a left tail test. So when you do your hypothesis test, step 1, remember, put your step numbers in a box. These will be boxed for you on the quiz or the exam, but if you're doing the homework, box these, okay? So this is your statement. Here we have HO and H1. H1. And we know that here we have sigma is less than 15. We have HO, so this is going to be, remember, HO goes the other way, so it's greater than or equal to, it includes all three, greater than equal to 15. This is a left tail test. It goes in the direction of H1 always. So this is a left tail test. Left, let me move this up and turn caps lock off so that it's not quite as in your face. This is a left tail test here, right? So we've got a left tail test now. And that's step one. Oh, and by the way, this is my claim, and I need to actually let me erase this because I forgot to put that. So let me erase this part. Let me put claim next to this. So I'm just gonna do this again here. Let me use a text box. This is my claim. Claim. And it is a left tail test. You can use the approximation if you choose. Up top, you can write the approximation of this, which the textbook will always write equals, which is why she doesn't, because it makes you think that every hypothesis test has two tails, and it doesn't necessarily. So HO here, your equivalent to this would be sigma. I'm just going to use an O, but I'll go ahead and put it in. Sigma here is equal to 15. This is my statistical equivalent. This is optional. This is step one. It did not say to use the p-value, so we're going to use the traditional method, which means we're going to get the critical value for this test. This is the next step. We're going to find the critical values. If you want, you can make a note up here that this is the traditional approach. I'm going to do it over here because I have more room. This is the traditional approach. And I know a few things. I know that obviously I know sigma is 15. Let me go back to the problem. Grab the information I have. So it says alpha is 0.05, random sample of 12 years, had a standard deviation of 13.6. So here I have N. This is N is equal to 12 years. Remember that by extension leads us to DF equaling N minus 1, which is 11. And my alpha, actually, let me write S. My standard deviation sample was 13.6. And my alpha was 0.05. Okay. So now I need my critical values. Now, how many critical values am I going to have? I'm going to have one because this is a left tail. So remember too, though, that in this case, there are no negative numbers. This is a chi-square distribution. So I'm going to have a positive critical value, but it's going to be on the left side of the curve. So I have a critical value, and I'll show you the procedure to find it. So here is my critical value. So let me show you that. This is going to be on your CVPV sheet. You have to go up to the chi-square values, critical values for chi-square test, and we're doing a left tail. So we're going to use 1 minus alpha with DF. That means you're going to use your inverse chi-square program, the one that she gave you or the one that you inputted into the calculator. So it's inverse chi-squared, 1 minus alpha, and DF. So we're going to have, this is going to be equal to inverse chi squared 1 minus alpha and df, like so, right? So then we're going to do this. We're going to say that this is equal to my critical value will be equal to inverse chi squared 1 minus 0.05. My degree of freedom is 11. So let's put that in the calculator and see what we get. Let me stop sharing at this time and share the calculator on my screen, which seems to have disappeared. Let me hold on here. One moment, please, ladies and gentlemen. Okay. My calculator is coming open. Here it comes. Bear with me for a moment here. All right, so now let me share the screen one more time. And we'll see what we have. This is, there it is. This is, remember your chi-squared is on your program. So we're going to go to program, inverse chi, hit enter, area to the right. Now remember, this is 1 minus alpha, 1 minus 0.05. Remember to use the big minus when you do this. Your DF is 11. So your critical value is 4.5748. 4.5748. So here you have oops, my apologies. This is equal to 4.5748. That's my critical value. Now I'm going to proceed to the test statistics. So now I'm going to say this is where my formula comes in. So now I have step 3 down here. This is going to be the actual chi-squared based on the sample data. So this is going to be my test statistic right here. So my test statistic is going to be my chi-squared, of course. This is chi-squared. And my formula for that is equal to, so I'm going to put that down here just to make it less confusing. This is chi-squared is equal to And remember, this is a fraction, so this is going to be n minus 1 s squared. This is s, whoops, s squared. Then I'm going to have sigma squared down below it. So this is going to be, go ahead and write it in, why not? This is sigma squared here. So now we just plug in the numbers to find it. So we have n minus 1. Remember, that's the same as df up here. So I have 11 times s squared. Remember here, they gave you the standard deviation. So they gave you 13.6. So we're going to square 13.6. So we have, this is 13.6 squared. And remember that your sigma was given in your problem. It was part of your null hypothesis. So this is, sigma here was 15. So we have 15 squared below at the bottom. This is 15 squared. So now this is equal to, let's put this in the calculator and let's find out what this is. So we have, let's go to the calculator here. I'm going to clear all this, quit from my program. Clear the screen one more time. There we go. Now we have 11 times 13.6 quantity squared. It's going to multiply first. Remember, if you have the pointer up to move it over, divided by 15 squared. That's what your question looks like. There's your chi-squared. 9.0425 if you round. 9.04248 rounds to 9.0425. So I'm going to go ahead and record that here. This is 9.0425. That's my chi-squared. Now, the next step is to actually test or make the decision about your hypothesis, your null hypothesis. Remember, this step is always about your null, not your claim necessarily. It's always about your null. In our case here, the claim is H1. So this is not about our null. It's about our, I'm sorry, it's not about our claim. It's about our null. So this is our decision. So we're going to either, the choice is reject HO or do not reject HO. It's what you'll see on the quiz or the exam. And what you're doing for the for the traditional approach is to draw this out and decide whether the test statistic falls in the critical region or not. This is a chi-square distribution, so we're going to draw a skewed distribution. That's the best skewed distribution I've drawn all afternoon. This is a left tail, so I'm going to put my chi-squared there. My critical chi, my critical value is 4.5748. So I'm going to say that my chi-squared critical value, my chi-squared crit, and I'm going to write the word crit down here. My chi-squared critical value is this one is equal to 4. This is where your 4.5748 is. 5748. That's your chi-square critical number. Now, remember, this is a left tail test, and this is 0 over here. So 0 is over here. All right, this is 0 here. This is 4 point. So your critical region is in here. Okay, this region is your rejection region as well. So any chi-square between 0 and 4.5748 would cause you to reject the null. Your test statistic falls. Your test statistic is 9.0425. So your test statistic, I don't know exactly where that is, but I do know that it's beyond 4.5. So maybe it's here, okay? I don't really care exactly where it is. The point is it's not in here. It's not in this green region. This is where my test statistic is. This is my chi-squared test statistic. So my chi-squared test statistic falls in, I'm sorry, it falls outside 9.0425. This does not fall in this region. So we do not reject the null hypothesis because we didn't fall in the critical region. We do not reject the null. And you write a justification. You say something like, oops, you say, do not reject HO because the test statistic does not fall in the critical region. Okay, that is our justification for step 4. Do not reject the null, because if it had, we would say reject the null because the test statistic falls in the critical region, but it doesn't. So now this leads us to our flow chart, which I'm not going to pull up for the sake of this video, but you can find the flow chart. You can find that in other videos where I go over it. But step 5, is to make our decision. So we write our summary here. Our claim was H1, and we did not reject the null. So some people will write both. Sometimes she'll ask you to do this. Your claim is H1. We know that from step 1. Your decision was do not reject HO. Therefore, your summary will read this way. Remember, your summary has to be exactly one of four statements. They're boxed. So you're going to say, because we have H1, we're going to have the word support in there somehow. And because we have not, do not reject the no, we can say, there is not enough evidence, and I'll come back and underline in a minute. There is not enough evidence to support the claim. Now, this is not as hard as it sounds. The claim, remember, was H1. You did not reject HO. Both of them cannot be sustained at the same time. So if you did not reject HO, you kept HO. Therefore, you still believe HO. And if your claim is H1, you cannot support that. So you're going to now underline is not and support. There is not enough evidence to support the claim. And that is number 3 from 8.5. I hope this has been helpful to you. And I look forward to seeing you in my next video, folks. Thanks for watching.